When we talk about big data, it's easy to think of it as just one giant thing. But the truth is, not all data is created equal. Some of it tells a really neat, self-contained story, almost like a detailed file on someone. And then other data, well, it's all about the connections between things. Today, we're going to dive into these two powerful worlds to really get a handle on how they shape, well, pretty much everything in our digital lives.
So first things first, let's set the stage. You might be asking yourself, why did we even need to move beyond the classic databases that worked so well for decades? The simple answer, the shape of our data changed, like a lot.
For the longest time, the answer to that question really seemed to be yes. We thought about data in neat rows and columns, like a perfect spreadsheet or a classic database table. But what happens when your data just refuses to fit into that neat little box? What if it's more like a messy family tree or a really complex user profile with all kinds of nested info? And that right there is the heart of the issue. The old way demanded that all data conform to the super strict, predefined structure. But the applications we build today, they're dealing with data that's messy, flexible, and just full of these deep interconnected relationships. We absolutely needed new tools that were built for this new reality.
And that brings us to our first destination, the world of document databases. We're going to use MongoDB as our guide here. I want you to imagine a massive digital filing cabinet. A place where every single piece of information is stored in its own complete, flexible folder. So what exactly is a document database? Well, at its core, it stores data in these flexible, self-contained units. This means there's no rigid structure you have to follow. You can add or remove fields whenever you want, kind of like just adding a new sticky note to a folder. Think about a single patient file at a hospital. Everything about that patient, their history, their visits, all their prescriptions, it's all kept together in one place, not scattered across a dozen different tables.
And the structure here is honestly refreshingly simple. You've got your main database, which is the big container. Inside that, you have collections. Just think of these as the folders for related information, like a student's folder. And inside each collection are the individual documents, where each document is one complete record for a single student.
Okay, so why would a developer choose this approach? Well, it's perfect for data that's naturally hierarchical, like a blog post that has comments nested inside it. It's also schema flexible, which is a fancy way of saying one student document can have a scholarship field while another one doesn't, no problem. And maybe most importantly, it lets an app grab or save an entire complex object in one shot, which is incredibly efficient and lines up perfectly with how developers actually write their code. And this is where you really see the magic. To find every student who knows Python, you don't have to write some crazy, complicated query that links a bunch of tables together. Nope, you just tell the database, hey, go look inside the skills list within each student's document. It's intuitive, it's fast, and it's built from the ground up for this kind of flexible data.
All right, let's leave the filing cabinet behind and enter a completely different landscape. Seriously, a whole different way of thinking. In this world, the individual records themselves are way less important than the web of relationships between them. So, welcome to the world of connections, which is powered by a technology called RDF.
RDF, or the Resource Description Framework, is not about storing self-contained files. Its entire reason for existing is to map out connections. So think of it less like a filing cabinet and more like a massive, interconnected social network, but for your data. Every single piece of information is just a simple statement about how two things are related to each other. The fundamental building block for this whole thing is called the triple. And it's as simple as it sounds, just like a basic sentence. You have a subject, a predicate that describes the relationship, and an object. So, Alice, that's the subject, knows, that's the predicate, Bob, he's the object. That single fact is one triple, one tiny link in this giant graph of data.
So why would you ever use this model? It's absolutely essential when the real value is hiding in the relationships. It's perfect for pulling together data from all kinds of different places to build what we call knowledge graphs, these vast networks of interconnected facts. Think about the info boxes Google shows you. That's a knowledge graph. And it lets you discover these hidden connections you never even knew were there.
Now let's look at how you'd ask a question here. You're not looking inside a document. Instead, you're asking the database to follow a path of connections. You're saying, find me a person who has a works for link to an organization, and does that organization have a located in link to Trento? You are literally walking the graph to find your answer. It's pretty cool.
So, we've got these two incredibly powerful but very, very different approaches. On one hand, you've got a library full of detailed books. On the other, you've got a map of all the connections between the characters in those books. So how in the world do you choose? Let's just put them head to head for a second. MongoDB is all about storing those rich, self-contained documents. It's a fantastic fit for data that looks and acts like an object in your application. An RDF triple store, on the other hand, is completely focused on representing the relationships between things. It's built for data where the connections are the most important part of the story.
Okay, this is basically the cheat sheet right here. This breaks down the practical choice. You're going to want to use MongoDB for that self-contained data, like user profiles or product catalogs. But you'll want a graph database, like an RDF store, when you need to connect a bunch of different data sources or find hidden patterns. And the weaker fits are just as important. Trying to force complex relationships into a document model gets messy fast, and using a graph for simple, isolated records is just total overkill. So the most crucial point, the biggest takeaway from all of this, is that it's never about which database is better. That's the wrong question. The real question is, what is the natural shape of your data?
Think about it like this. Are you managing a collection of individual, rich stories where each document tells you everything you need to know about one specific thing? Or are you trying to map out a vast, intricate web of connections where understanding the relationships between everything is the entire point?
At the end of the day, every single dataset has a story it's trying to tell. Choosing the right database is really just about choosing the right language to tell that story as clearly and as powerfully as you possibly can. So the question I want to leave you with is, what language does your data speak? Thanks for joining me for this explainer.